All right, guys, so we're looking at your notes from yesterday, Investigation 2, and we talked about product rules, and we worked on some of those problems with Miss Sims. And now we're going to be looking at some quotient rules. So, for example, we have 2 to the 10th being divided by 2 to the 3rd. So just keeping in mind I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 twos up on the top that are all being multiplied times each other. And on the bottom I have 1, 2, 3 twos. So we want to simplify this. So if I have the same thing on the top and on the bottom, I can cancel those out. So those two cancel out. Those two cancel out. And those two. So I had 3 twos on the top and on the bottom that canceled each other out. So what I end up with is I end up with 1, 2, 3, 4, 5, 6, 7 twos. So I end up getting 2 to the 7th power. So x is 7. So like looking at this example, I have 1, 2, 3, 4, 5, 6 threes on the top. And then I have 2 on the bottom. So once again, we can cancel out things that are like each other on the top and the bottom. And it looks like I have 1, 2, 3, 4 threes. So I get x to be 4. So is there a quicker way for us to look at it? So I had 10 up here, and I had 3 down here, and I ended up with 7 as the exponent. I had 6 on the top. I had 2 3s on the bottom. And I ended up with 4. It kind of looks like I can just subtract those exponents. So if I have a to the m, or like if I do 2 to the 10 minus 3, does that get me 2 to the 7th? Yeah, it does. So all I have to do is just subtract the exponents. Like here, I have 10 to the 9 minus 3 gets me 10 to the 6th power. So that exponent turns out to be 6. So here, I'm trying to figure out, okay, what do I have to subtract 5 from to get me 2 to the 7th? So what do I have to subtract? So if I think about x minus 5 equaling 7, I think it looks like x is just 12. All right. So let's look at a couple examples underneath here that kind of apply this property. So in this case, I have 4, and then I have 1, 2, 3, 4, 5, 6, 7 y's. I have a 7 on the bottom. I have an x, and then I have 1, 2, 3, 4 y's. So in this case, we're just going to want to cancel things that are like each other. So that y cancels, that y cancels, that y cancels, that y, and that y cancels. 4 and 7 don't simplify, so we're okay with that. So it looks like I have an x on the top, or on the bottom, sorry, and then I have 1, 2, 3 y's. So I get y to the 3rd. So I could easily have done this with the y's. I could have just done 7 minus 4, just taken this exponent and subtracted that one, and I would have ended up with that answer right there. So let's look at another example here. I got 2, and then I have 1, 2, 3, 4 x's, and then I have 2 y's. And then I have 8, and then it looks like I have 1, 2, 3, 4, 5, 6, 7 x's. So we just want to cancel things that are like each other. So it looks like those 2 x's cancel, those 2, and those 2. So right now, it looks like I have 2 y's on the top, and on the bottom, it looks like I have 3 x's. Now let's look at 2 and 8. Does that simplify at all? Well, does 2 go into 8 at all? Well, it looks like 2 goes into 8 4 times. So it looks like I have 4 x's on the bottom. So I end up with y squared over 4x cubed. So what I'm going to ask you guys to do is just to pause the video and just try this next couple for me. Let's see. Pause video. And hopefully what you guys got, you already did that one. Let's see here. For G, for that first one, you should have gotten, for G, I got 1 over 2, a to the 5th, b to the 4th. So 2, I have 2 a's on the top, 7 on the bottom, so it leaves me with 5 on the bottom, and b to the 4th is by itself. For this next one, I got m to the 5th, 3m to the 5th over 4n cubed. All right, so let's just look at this right here. We have 3 over 5 to the 3rd. So if you guys keep in mind, I have 1, 2, 3 threes, and then I have 5 3 times, because I have 3 of each of these. So it looks like each of those are being taken to the 3rd power. Here I have c over 5 times c over 5. So it looks like I have 1, 2 x's and 2 5s. So it looks like all I have to do is just take each of these to this power of m. So just to apply that here, all I have to do is I have x y to the 4th times x y to the 4th times x y to the 4th on the top. And on the bottom I have x squared y cubed 3 times. So if I were to simplify this up top, it looks like I have 3 x's, and it looks like I have y to the 12th on the top. And then on the bottom, it looks like I have 2, 4, 6 x's, and then 3, 6, 9 y's. So let's look at the x's here. Well, what has more x's, the top or the bottom? And it looks like the bottom has more x's, and it actually has 3 more x's. The y's, which has more, the top or the bottom? Looks like the top has more y's, it has 3 more. So it would just be y cubed over x cubed. So here I have 4 m to the 4th. And then it looks like I have 4 n's on the top. And on the bottom, it looks like I have n squared, m squared, m squared, m squared, and then it looks like I have 4n to the 6's. So overall, if I look at my m's, it looks like I have 16 of them, and then I have 4 n's. And on the bottom, it looks like I have 8 m's, and I think I have 24 n's on the bottom. So if I simplify this, which has more m's, it's the top, and I have 8 more m's. And on the bottom, I have more n's, so it's what you should have gotten for that. I'll pause the video and just try the next couple for me, okay? So try these for me, and hopefully you guys got this. I got x to the 30th over y to the 6th, and then for this one I have 1 over x to the 16th, y to the 24th. So if I look here, guys, I have 8 x's and 24 x's on the bottom. So that means I have 16 more on the bottom, and I can't leave the top naked, so I'm just going to leave that with a 1. Hopefully this helps out, guys. You're going to be doing some more work on this just to practice it out, so good luck.